Alright, so this is your kinematics quiz. I've posted this because I want you to test your knowledge in uniform motion, kinematic equations, free fall, and motion on an inclined plane. There are 3 questions, and what I want you to do is pause this video and attempt all 3. If you get stuck, just skip to the part of the video where I have explained the answer. For those of you who want to go at it alone, what I'm going to do is write the answers right now, so you can try it and compare your answer to mine. And if you have no idea where to start at all, just keep watching the video because I'm going to jump right into our first question. So in this question, we have a skater who glides across frictionless ice at a constant velocity of 10 meters per second, and this takes them 10 seconds. The skater then reaches a rough patch of ice and starts slowing down at a rate of 1 meter per second squared. So we will write that their acceleration is equal to negative 1 meter per second squared. If you're confused where the negative came from, let's look at the velocity and acceleration vectors. The velocity vector is pointed to the right, and if the object is slowing down, then the acceleration vector has to be in the opposite direction, so it would be pointed to the left, and that means the acceleration would be negative. And so the skater slows down at this rate for 5 seconds. Then they hit smooth ice again and continue at their current velocity for 10 more seconds. And what we want to know is the total distance that the skater traveled. So that means we want to find the delta x for this first part of the motion, the delta x for the second part of the motion, and the delta x for the third part of the motion, and then we want to add them all together. Now I hope you realize that the first part of the motion is uniform motion because the skater is moving with a constant velocity. And that means we can use our v is equal to delta x divided by delta t equation. The second part of the motion will require you to use your kinematic equations, and I know this because the object is accelerating. And finally, the third part of the motion is uniform motion. And I know this because, again, we're told that the skater is moving with a constant velocity. Let's start solving by looking at the first part of the motion. We know that the skater had a velocity of 10 meters per second, and they skated for 10 seconds. We can use our v is equal to delta x divided by delta t equation, rearrange to isolate for delta x, and then just plug in our values. And what we find is that the change in position for the first part of this motion is 100 meters. Now let's move on to the second part of the motion. We know the initial velocity was 10 meters per second, the acceleration was negative 1 meters per second squared, and the time was 5 seconds. Based on what we know, we can use the xf is equal to xi plus vi delta t plus 1/2 a delta t squared kinematic equation to solve for our change in position. All I have to do is move xi onto the left-hand side, and now I have our change in position for the second part of the motion. From there, I'll just plug in the values and solve for delta x. And what we find is that the change in position is about 37.5 meters. Now onto the third part of our motion. All we were told is that delta t is equal to 10 seconds. So if we are to use our v is equal to delta x divided by delta t equation, we need to know v. So how will we figure out the skater's velocity? Well, we have to go back to the second part of our motion. Using the second part of our motion, we can solve for vf, the skater's final velocity as they leave the rough ice. Since we have vi, a, and delta t, we can use the vf is equal to vi plus a delta t equation, and all we have to do is plug in our values and solve for vf. And what we find is that the final velocity when the skater leaves the rough ice is 5 meters per second. With that, we can rearrange our v is equal to delta x divided by delta t equation to isolate for delta x. All we have to do is plug in our values, and what we find is that the change in position is equal to 50 meters. Now we are done the hard part of this question. All we have to do is add up our change in positions. So we have 100 meters plus 37.5 meters plus 50 meters for a grand total of 187.5 meters. And that is the answer to our first question. Now on to our second question. Here we have a bridge and we have a watermelon that gets dropped from the top of the bridge. The watermelon falls 50 meters and we want to know what is its velocity as it hits the ground. Before we jump into solving, I hope you understand that this is free fall motion. I know that because the only force acting on the watermelon as it falls is gravity. So that means the watermelon is accelerating due to gravity. And that acceleration is always equal to negative 9.8 meters per second squared. Now let's look at what we know about this situation. We were told that the watermelon is dropped from the top of the bridge, so we know the initial velocity is 0 meters per second. We also know the change in position is 50 meters. Since we have the acceleration, change in position, and initial velocity, we should use the Vs squared is equal to Vi squared plus 2a delta y kinematic equation. And all I have to do is plug in my values and solve for Vf. But remember, when you take the square root to isolate for Vf, a square root can be positive or negative. So what is our answer? Is it positive or negative? Well, it would be negative 31.3 meters per second. And I know this because the velocity vector is pointed down. And that means the velocity has to be negative. Now for our final question, we have a skateboarder who's gliding with a velocity of 10 meters per second, and they're approaching a ramp. This ramp is 5 meters tall and 8 meters long, and we want to know what will the skater's velocity be as they launch off the ramp. Now this is motion on an inclined plane, so we know the acceleration will be equal to plus or minus g sine theta. Now how will we find the angle of the incline? Since we have a right-angled triangle, we can find the angle using trigonometry. So we know our hypotenuse and our opposite side, which means we can use sine theta is equal to opposite over hypotenuse to solve for the angle. All we have to do is rearrange and isolate for theta, plug in our opposite and hypotenuse, and we find that the angle of the incline is equal to about 39 degrees. And with that, we can solve for the skateboarder's acceleration. All we have to do is plug in our values, and we find that the acceleration is equal to about negative 6.2 meters per second squared. Now, how did I know it was negative? Let's look at our vectors. The velocity vector is pointed to the right, and we know an object going up an inclined plane will be slowing down. So the acceleration vector has to be in the opposite direction. That means the acceleration is to the left, and so it is negative. Now we also know the initial velocity of the skateboarder, which was 10 meters per second, and we know the skateboarder's displacement, so delta x is equal to 8 meters. Based on what we have, we should use the Vf squared is equal to Vi squared plus 2a delta x kinematic equation. All we have to do is plug in our values and solve for Vf. And we find that the final velocity as the skateboarder launches off the ramp is about 0.89 meters per second. And that makes sense because the skateboarder would have slowed down as they went up the ramp. So their final velocity is a lot smaller than their initial velocity. And with that, that is the end of the kinematics practice quiz. I hope the answers to these questions made sense, and if they didn't, then go back and watch the other kinematics, free fall, and motion on an inclined plane questions to keep practicing and testing your understanding.